Well, welcome back to the second installment of LeetCode, 30 Days of Coding. So we got the second problem today. It's a happy number. And let's get happy. Okay, let's think about this problem. We'll read it out first, and then we'll go from there. Write an algorithm to determine if a number is happy. So let's start detailing what happy means. So problem, write an alg to determine if num is happy. We don't know if it's an integer or if it is a float or if it's one of these. We have to keep reading to see if we need to control for the input. I'm going to put happy, so we can start writing out what happy means. Happy number is a number defined by the following process. Starting from a positive integer, replace the number by the sum of the squares of its digits. Okay, I need to digest that for a second. Replace the integer with sum of the squares of its digits. Put a little example here to the side because that's going to look, let's say with the number 18, we would break that down into 1 squared plus 8 squared, which would give us 66. Oh, no. 1 squared is 1. It'd be 5. 65, not 66. Okay. So that makes sense. Let me just reread that to make sure I've got that right. Starting with a positive integer, so greater than 0. Replace the number by the sum of the square of its digits. And repeat the process until the number equals 1. So repeat this process until the number equals 1. Some numbers will loop endlessly because they can never get happy. The numbers for which this process ends in a 1 are happy numbers. Okay, this makes sense. So basically, this is a classic recursion problem. And we can optimize it with passing an object alongside the recursion function. I think I'm getting a little ahead of myself because I'm excited about the solution because I think it'll work well. So let's break down the example. Just make sure I've got it on a lock. Oh my gosh, can't even spell it. Okay, we got 19, and that's going to be true because it ends with a 1, which is our base case. So the explanation is 1 squared plus 9 squared is 82. 8 squared plus 2 squared is 68. 6 squared plus 8 squared is 100. 1 squared plus 0 squared plus 0 squared is 1. Okay. So long as it ends with 1, we're good to go. I think a key thing to notice in this question, or this example, I mean, is that the sums never repeat themselves. And if the sum repeats itself at any point during the recursion, we know that we're going to enter an infinite loop. Because if 82 ended up here again, we would just keep repeating 82, 68, 100, 82, 68, 100, and it would never end until the stack just ran out of space. So we need to have some way to track the count. Well, not the count, because if we see it more than once, we know it's we know to return false. So we just need a way to store the numbers that we've seen. We don't need to keep a count of them, really. We just have to say that we've seen them, and it's true that we've seen them. So we could use a Boolean, even. So this brings us to a data structure. We want to use recursion. I know that's not a data structure, but it helps me frame this next part. Recursion, and we want an object passed into the function which stores sums that we've seen. Because otherwise we'll never know if we're in an infinite loop. We have to keep track of it somehow. And this is the best way I can think of off the top of my head. So the algorithm is like just we wrote up there. Invoke function is happy. Function is happy. Now, what's interesting about this problem is I'm not sure. Because the way it's set up, I don't know if I can add another, so like I want to pass this object here. I don't know if I can pass it in like this. I'll try it iteratively first. So I'll do it iteratively first, and then I can try recursion after, see if it works. Invoke function, I need to put that. Starting from n, while loop, and in an arbitrary iteration, we split num into its digits, and we can do this with a, converting the number to a string, then splitting it, and then mapping over the collection and converting each to a number into an int. So number to digits, then square each digit and sum them. If sum is equal to 1, return true, else store sum in object and assign it true. Okay, so yeah, so if sum equals 1, return true. Then we also need to check else if sum exists as a property in object. So if it's truthy in the object, then we know return false because we've seen it before. And then else we're just going to continue looping with that new n. So we're reassigning n each time to a new number. Okay, there's our algorithm. Just read over that again. So let me think about it. Start from n, enter a while loop, split num into digits, square each digit, sum them. If the sum equals 1, return true. Else if, yeah, this makes sense. So let let sums equals empty object while n I'm going to have a little base case here, just if n equals 1, return true, just to be safe. While n is while n is not equal to 1. We're going to do this. So now I need to figure out the way to split the number into its digits. So I'm racking my brain on ES6. How do I, trying to think of how to convert it. I think I just do, I'm just gonna comment that out for a second. I don't want to get into the loop yet. Let's try const log n to string and see what that gives us. See if it comes out as a string. Okay. So that's giving us the right thing there. Let's try n to string split like that. Good. And then map num to integer. I don't know if that's a, yeah, it's not a function. Let's look up what that is. Convert string to int JavaScript. Parse int, that's the one. No, not W3. Ugh. So it's terrible. MDN, that's where it's at. Okay. Parse int, we don't need to, it's just a function. We don't need to use the math class. So parse int, see what that does. Nice. Okay. So we've got our way to split the number into its digits. Let's save that method, and here are the constant num to digits function num, and it returns all of this good stuff. So we've got it split nicely. I think that's half the battle, honestly, is getting it split the right way. So n is equal to num to digits num to digits. What am I passing it? N. Oh my gosh, lost my brain there for a second. Num to digits. Then next, what do we got to do? Square each digit and sum them. Let's make a little function here also to do that. So we're going to name this square digits and sum. We can do both in the same. It's not that big an operation. Let's run this to R. So I'm going to use reduce to add them together, and we're going to use them. We're going to need to use map to square them. So let's do let squares equals R map num and num times 2 I'm going to do turn squares dot reduce I'm thinking correctly, I think the first one is the current and the next one is the accumulator. And we just add them together. We're just going to return after this so you can see it. And we're going to do console log square, digits, and sum, just so I can check to make sure we're actually getting the right thing. And I'm returning so we don't end up in our loop. I don't feel like dealing with that at this point. Okay, we've got the right squared digits. That's good. So we can just reassign it again here. And is equal to square, digits, and sum. Actually, we'll make that a new variable just to keep better track of them. Okay, now we need to do our checking. If sum is equal to 1, return true. Else if sums sum is equal to true, return false. And that's basically checking if that number has been seen before. So if that sum has been in the loop before, we know we're repeating ourselves and there will never be a happy number, as sad as that sounds. Else case, we don't need else. We can just do whatever we need to after that. Then I'm going to put return true there just because if for some reason this did not catch that n is 1 and it breaks out of the loop, we can assume that it wasn't an infinite loop, which means that n is equal to 1. So we can just return true. I don't think it'll ever get to that point because it seems pretty foolproof, but we'll see. So here, what's the next part of the algorithm? Store sum and object. Sums, sum, true. And that is the last step in the loop. Let's see what we get if we run this. Okay, we got false. Oh, I need to reassign. N is equal to sum. Okay, that was good. True. We got true. Let's just put some random numbers in here. Let's see what comes up. Let's do 54, 101, 1, 23. I don't think 0 is a positive integer. I don't think it counts as 1. So 34 and 9,322. Okay, let's see. True, false, false, true, true, false, false. That's good. Let's throw a 0 in here and see what happens. Nice, we got the right answer. Maybe we can't assume there's not going to be some negative numbers in here. Let's see. Nice. Maybe we can change that base case here. If n is less than or equal to 1, we can return. Oh, actually, no, we don't want to do that. Let's leave it as is. So we got the right answers there. It looks good. Let's try 10,000. Good, we got the right answer. Seems pretty solid. Let's submit and see what happens. Okay, it's accepted. Nice. Let's see how we did on the time. Nice, 84% of JavaScript, pretty good. Yeah, I feel pretty good about that solution. That looks pretty good. We're gonna go back here. And I want to just walk you through what I thought I would do for this recursively. So basically, let me just enter down here a couple of times and I'll just rewrite is happy. So constant is happy. I only didn't do this because I'm not sure if I can add parameters to their function. Um, and and then here I would pass in an object. Now initially, by default, it's just an empty object. And we're going to take a lot of the same stuff. But we're just not going to do it iteratively. We're going to do this recursively. So we need a base case, and the base case is if n equals 1, return true. If object n equals true, return false. That means we're in an infinite loop. And then here we're going to do let, we're going to reassign n to num2 digits. We're going to say let sum equals squared digits and sum n. And now we're going to say if sum is equal to 1, return true, else if object sum equals true, then return false. And now, since we've checked if the object already has sum on record, we can rest assured it's not in there if we didn't return false. So we need to say object sum equal to true. And then instead of reassigning n, we just do return is happy with the sum. Let's see what happens with this. Oh, we also need to pass the object in there. Let me see what's happening here. Let me print out sum here at the end. I'm thinking that this is actually correct, and it's just not taking that extra object. So let's open up a REPL and see what happens. So we've got base case, it's our test case. We've got 19. 19 will return 1. Let's try is happy, 19. And the object is a default parameter in there, so it's just going to pass itself. We can just leave it with nothing, and it should work. Let's see what happens. It's coming up false. Huh. What is going on here? Let's see. We're going to be able to get better debugging from this, I think. Let's do console log sum. So as soon as we're hitting 82, we are returning false. Oh, okay. Because we put it in here. Let's try now. Okay, that worked. Let's try it back on LeetCode. And because I had the base case to return, and of course it was returning early because we just assigned the previous sum to the object, and we're checking that for second once we recurse. So it's of course going to return early. I don't know why I didn't see that. So I was writing it. Let's try down here. Okay, it's true. Let's try 45, 1, 0, 10,000, 34, 9,322. Okay, all good on that. That's good. Try -1, and then just that number. 4 falses, a true, false, true, false, true. Okay, and let's submit it. See what happens. Accepted. Okay, so we did this 2 ways. We did it with dynamic programming and memoization, which is where we pass an object to keep track of previous previous recursions, so we don't waste time and end up in infinite loops. And we also did it iteratively. So not bad. And this is a good example that recursion isn't always faster than iteration, because in this one, we had 88% JavaScript submissions were beat by the iteration algorithm, whereas 66% were beat by the recursion algorithm. So something to think about. I think that's all. Feel good about it. Thanks for watching. Have a great day.